Hey, I'm Caitlin. So, as John just said, I'll be talking about discovering the submerged landscapes using GIS. So, I'm a PhD student at UWA. I did previously work in the environmental science industry as a GIS analyst and data analyst, and a bit as an environmental scientist as well. So, I've just come back to UWA. My PhD is a little bit on the stranger side. It's very multidisciplinary. So I'm looking for submerged rock art, so petroglyphs, up in Marajuga, which is near Dampier. So all that land there actually used to all be exposed, a lot of it. So that we know that there's a lot of heritage locations under the water. It's just about finding them. So we've got over 1 million recordings just of rock art, just on those islands and on the Burrup Peninsula. So that's a lot of recordings. So we know there's a lot of other stuff underwater, and it's obviously quite important to preserve these things for the local custodians and for their history, because all their history is written in the rock art, especially with a lot of pipelines and mining going on in the area. So that's just the context to all this. And yeah, I also like fly my drone in probably some silly locations. So I'll be chatting today about how we use GIS for searching for submerged Indigenous heritage sites and how we investigate those submerged landscapes. So this sort of process involves several steps, but I'll only be talking about very few today. So the first part of this entails looking at the history of the sea level to see what land might have been previously exposed. We then want to look at the landscape features within their environment and identify the relationships between the features and their surroundings. So to do this, we have to analyse and classify the terrain, and then identify possible analogues, so features that have a lot of heritage sites on land and similar features underwater. So all of this is done using geospatial analysis, obviously. So why do we look at the submerged? People may not realise, but the current sea level is a lot higher than it was throughout most of history. So even within human history, which is on the green and the orange lines down the bottom here, sea levels were a lot lower, so up to 120 metres below what they currently are. In reality, this means that there is hundreds and hundreds of square metres of land that was exposed for, the majority of human history, just not necessarily our history. So in WA, this is especially prevalent. So, and the orange line there, by the way, is what we pretty much have evidence for Indigenous people occupying Australia. So that's a lot of years. So got a video up here. So this is of between Perth and Rottnest, and you've got the years at the top. So it went back to 60,000 years ago, and what the sea level is in comparison to current. So as you can see, it does fluctuate, but those white lines there are the current coastline, and that little one there is Rottnest. So all of this used to be connected and was for a very, very long time. So how do we figure out what land was exposed and when? Scientists over the last 50 years and over the last century have come up with a lot of different sea level curves, indicating approximate sea level heights based on a whole lot of geological and geomorphological evidence. The sea levels can vary a lot throughout the world, so there are a lot of different curves, and they can vary your sea level a fair amount. So it does depend what sea level you put into what outcomes you actually get. So the one I'm using today is Grant et al., which is sort of accepted as a global standard, but most importantly, it's open source, and you can find it online on Nature, on the Nature Journal, and they've got all the supplementary materials. This GIF here wasn't made by me. This was made by my colleague, Patrick Morrison. So he's the genius behind the original sea level QGIS plugin. So do have a look at the QR code if you can, or Google that, because it's a really good QGIS little plugin. Yeah.
Does it work globally or just here?
Globally. So you can input whatever curve you want. So you can input the Grant curve and use that globally. If you do actually know some other curves which are good, you can input them yourself, and you can input any of the raster data. So it's just elevation model you'd be inputting. So that one's up on, it's on GitHub. It's also on the QGIS repository. So I've also adapted that one to use on Google Earth Engine. So if anyone doesn't use GIS, which obviously here I don't think that's many people, so I've made this because a lot of people were asking Patrick about how they could use it online because they didn't know how to use GIS. So there is a Google Earth Engine version which is free to use. So there's also the scan there, but it's not very good on your phone because it's obviously Google Earth Engine's not really made for phone usage. It's definitely more for a computer. And this one uses the GEBCO imagery, which is freely available. So obviously the resolution's not as good as if you were to input your own elevation data in QGIS, but it's available and it still gives you a really good indication. So on the app, you can swipe through to look at, you can compare 60,000 years ago on the right and current, and then you can swipe through. You can also make a little GIF. It's just got to be of a small area. If you're looking for a really good GIF, I would recommend using the QGIS one because obviously it renders a lot better and you can use higher resolution imagery. But this is a good one if maybe your computer won't do anything, which I do have trouble with my laptop actually rendering with QGIS. So once we know if it was exposed, we do want to know how long was it exposed. There's obviously a higher chance of a site containing heritage features if it's been exposed for longer, especially during human occupation. So the orange area up on the map here is actually, it's area of land that is now underwater. So the black line's the coastline. This is northwest WA. The orange area has been exposed for about 50 to 60,000 years, so most of human occupation of WA. So obviously that's all underwater now, but it probably would contain heritage sites, seeing as we know that Indigenous people have lived in that area for 50,000 years. So these are areas that archaeologists are starting to target to see if we can find underwater heritage to contribute to the overall stories and overall history of the people of the area. So Murujuga is like that little peninsula to the right of Barrow Island, and really small island. So we've got all up in that orange area is all underwater now, and those tiny little islands there, we have over 1 million petroglyph, so rock art recordings. That's a lot. So we know there's definitely some between the islands, and there's some a little bit further out before the shelf drops off. And not only is this useful for heritage, but it can be useful for environmental, geological, and geomorphological applications. A lot to do with how the land may have weathered because it was actually exposed, which may not have realised before. And the data, the elevation I'm using for this is actually available on the Geoscience website. It's a combination of some industry bathymetry, some satellite-derived bathymetry made by Lebrec, who just finished his PhD at UWA, and there's some really good elevation data sets he's made. They're fantastic. So if we know an area has been exposed for a significant amount of time, we want to target locations that are likely to have heritage sites. We know that there are specific land features that are more associated with cultural heritage. For example, near the top of a ridge, there's more likely to be more rock art. If there's a rock outcrop on top of a hill, it's more likely to be there because people probably went to the top of there to look for things. Or near waterhole or any other sort of water source like a river, so a riverbed. So those are the sort of features you're probably going to want to be looking for. And the same patterns that exist on land are likely to exist submerged. So if there's a lot of rock art in a certain location on a certain land feature on land, well, if you can find a similar land feature like that underwater, your probability of having rock art on it is a little bit higher. Yet again, it's all probabilities until you actually send a diver down. But we want to reduce the amount of places they're going to have to look because it's costly, very expensive, time expensive, and can be a little bit, go on the dangerous side. So traditionally, archaeologists used a lot of manual inspection of digital elevation models. As any GIS specialist here would know, if you're just visualizing a dam, you can miss a lot of features. If you've done the symbology wrong or you're not putting a nice hill shade underneath, you're probably not going to get the full picture of it. With my research, I'm hoping to move towards a more geostatistical and machine learning approach for detecting and classifying features that might have heritage. So the first step of that is to identify those features from underwater. Obviously, if you're underwater, you don't usually have any sort of like pictures or aerial images. You're just working off elevation data. So we have to figure out how to use that elevation data appropriately to find those features we're looking for. So we found that using a lot of terrain derivatives, so anything like aspect, slope, topographic position index, any relative position indexes, that sort of thing, are really good at drawing out the features. The human eye is also way more capable of interpreting hill-shaded objects than just your one-banded imagery. And machines are the same. They can draw way more information out of a terrain derivative, even if you just give it a few different ones, than it would off just an elevation one. Obviously, it's a little bit harder to probably find, what is a rock out of just an elevation profile than it is to find it out of, a combination of your topographic position index, your slope, your aspect, that sort of thing, and to classify them. So it just makes the information way more directly available to machines as well. White box tools has been really important for me in this one. Although they did put some of them behind a paywall recently when I was halfway through my analysis. So these are just some quick ones that I found really useful so far, especially in high resolution imagery. Slope has been amazing for drawing out the edges of any features. So when I'm trying to find the edges of rock outcrops, that has been really good. But TPI, so topographic position index, is currently my favorite. You can really see the nice features between things. And then depth and sink is for finding like waterholes. As I said before, waterholes we know are a feature that people are likely to have congregated around. And that's, finds it really easily. Yeah.
Sorry, topographic position index. Could you explain?
It's like a relative position within your immediate landscape. I don't know the exact equation, but I can send you a link if you want to have a look at it. Yeah, it's literally just like relative position, a little bit more complicated than that. But I find that it really draws out, it sort of draws out a little bit of the roughness of your rock as well, if you've got high resolution, unless your data's not filtered properly. And then it also, it makes the shapes quite good. So, for example, this here is a submerged data set on the left, and then on the right is one of the terrestrial data sets. These are the same resolution. You can actually, there's a few artifacts in this, which isn't great, but you can still see, you've got rock features on the right here, which I've verified because they're on the land. I've looked at aerials. You can also see similar features on the right here. So they're likely to probably be rocks, and that's using TPI. But if you just look at the elevation, you can't see that at all. A key part of the research, though, is customizing the open source models to find these features, because obviously, how are we going to classify features over such a large area, even if you're just looking at a small outcrop underwater? That's a pretty big area, and it becomes way too subjective if you're just going to say, I think that's a rock, going down and doing that. So I've been adapting models to detect these features, so for me, rocks, based on object detection, pixel classification, and some machine learning. For my research specifically, I'm looking at the rock features and the rock outcrops because I'm just looking for rock art, because a PhD can't really look at absolutely every heritage site. As I said, we don't have imagery, so I just have to look at the terrain derivatives. Little side note, these guys actually made a little shipwreck detection model just using hill shades as well. It is an Esri model though, but you can actually view their results online, and it's pretty good. It's just a nice little handy one to show that you can just use elevation derivatives to find these sort of locations. They did have recorded sites underwater, so they could use that to train all their models. And this is something I don't have, so I'll just wait until people have taken that one. And you can actually use and retrain this model, by the way, online. So how do you train a model if you don't have recorded locations underwater and you don't know the landscape of the underwater yet? As I mentioned, you need to classify the underwater landscape, but contextually. So I'm looking for rock art, so I should probably detect, quantify, and classify the actual rocks underwater. So I need to be able to discern from the elevation and terrain derivatives what is rock and what is not. We can confirm what is a rock and what isn't on land. So what I've done so far is I'm creating a model on the terrestrial data, testing it terrestrially, and then applying that to the same resolution underwater. So I've been testing and refining some open source instance segmentation algorithms, and then some identification and classification models. I've honestly been spending the last few months testing a bunch of different ones and just sort of seeing what happens as well. So I use the high resolution segmentation on the aerials to distinguish the rock shapes to start to sort of make my training data, because from then I actually have to go edit a lot of rocks, and I was trying to decrease the amount of manual drawing and identification I've had to do. That being said, I think I did my wrist from like 6 weeks to straight up just tracing rocks. All you see is rocks by the end. Like, I look at anything and you just see the outline of a rock. So I was glad I did that to actually reduce a fair bit of it. The best one for this has been SAM, so the Segment Anything model by Meta, and then developed for GIS by Kusheng Wu. I think that's, yeah. It's been absolutely amazing. So up in the right-hand corner, that was the initial, I just put the orthomosaic through, and that's the sort of result it gave me. And when you consider the fact you're not doing anything extra, you're just running it through the model, that's pretty good. I then had to refine it from there. Also, I did find that when the model was first released in like March or April, when I ran it through, it was really good. And then they've done a lot of updates, and now I can't get it to run as good. So if anyone knows, that would be great. I do not know what they changed, and I've tried every single setting. Because it used to be amazing. And I'd only run it on like 2 islands by that point, so I need to run it again. Yeah, and then, so once I've got the training set, made, so this is an example of one of my training sets here, I'm then using that to put through different like identification and classification algorithms. So I've been using some based on UNet and Marscar CNN to classify combinations of terrain derivative layers. So I've been trying it on your TPI and just slope and your aspect, and then also combining those into RGBs just because it's a little bit quicker to run, and seeing what we can classify as rock and not. I'm still doing this process at the moment. I'm getting reasonably good results on some of the islands, but some of the other ones it's a little bit overclassifying, so still getting there. But it's definitely showing that we can move towards this sort of process. Obviously, you need to actually verify by going underwater and checking all the rocks, so in about 2 years I know how well it really works, which is a little bit terrifying. Yeah, it shows that if we have high enough accuracy on these models, we can do this where we actually start to classify just based on elevation, which is better than classifying on your orthomosaics as well, which can get really, really large, and your computers might not like them too much. Yeah. Just briefly, a few little issues that come up and how to move forward. So data resolution is not really available open source for especially for bathymetry, for features you might be trying to find. So for example, for me, I'm looking for rocks of all different sizes, but you need quite high resolution to be able to discern what a rock is from vegetation, coral underwater, because you need to be able to find the roughness. So you need that to be quite high resolution, which just isn't available publicly most of the time. So maybe moving towards that eventually. Computer abilities being a pretty obvious one, though Google Colab is getting pretty good at getting around those things in remote computers. Data collaboration, obviously you can have much better models and any sort of modeling if you have way more data. So in terms of like archaeology and heritage, having data, like publicly available databases where you can see how sites are related to their environment would be pretty big, and a few people are trying to make databases like that that are actually publicly available. Yeah, I think that's it. So thanks. Any questions?
Thanks, Caitlin. Fascinating topic, fascinating research.
It's a bit different.
Who's got some questions?
A couple of questions. Do you try and build up what the underlying lithology is as well as the holes?
Not quite.
And do you make an assumption that the current profile is what it was, or do you?
Yeah, so based on what they know of the area, they're quite sure it is. So there's been a lot of other research done before me for the last quite a few decades, and they can assume that it hasn't changed too much based on the geology of it. So the areas we're looking at specifically, some of them are so it's called Gidley Granophyre. I don't know the geology well enough, but I know that they've decided to search this particular location because they're quite convinced that it's actually it wouldn't have changed too much. But in other places of the world, like any of the sedimentation processes have definitely changed underwater. So, you know, these sort of sea level curves definitely don't account for anything like that, which is why, you know, you do need to understand your actual regional geology and morphological processes and that sort of thing. But yeah, for ours, specifically in Murujuga, they think that it hasn't been affected too much by any of those processes in the time that humans have occupied it. Yeah, because that was my first question when I started the PhD. Yeah.
Have you tried any of the underwater, well, using the underwater drainage models to sort of see what happens to the hydrology if that surface was exposed?
I haven't, but I know someone else I think has been looking at that. There's another PhD student in my group who's looking at the hydrology of the area. Yeah, that will be integrated at the very final stage, from what I understand. Because obviously we had to reduce the amount of things you look at in a PhD because it ends up like this big. Yeah, but it is a really good one to look at because we know people are obviously drawn towards any sort of water sources, so knowing where the hydrology is going underwater would be good. But we have looked a little bit about where some of the possible riverbeds might have been flowing. So you know that coming out of like just north of Dampier, there's one of the rivers that runs through, and so that probably went a little bit further. Yeah, it would be good to understand a lot more though. Yeah. Yep.
So, say if you have identified heritage on the seabed, how would you validate the heritage using this special data? So, if I understand correctly, like you might have satellite imagery, not from Greece, but it's in processing data. Like, how would you know
If you're correct.
if you're correct?
Yeah. We send divers down. So I'm a part of the Centre for Rock Art Research, but we also collaborate with Flinders University, who have a whole maritime archaeology department, and they train divers, and they've also been training divers at the Murujuga Aboriginal Corporation, so that eventually they'll be ready to go down and look at the sites as well. So we literally send people down to dive. You do also sometimes use the robots, but funding is the biggest one. Getting someone to fund divers or a robot to go down is a big issue, so it will be at the end of my project or possibly after my PhD is done when you find someone to go do it. Yeah, it's literally people have to go down there and look, or maybe we'll have some really good robots within a year or two and then they can go check. Yeah. Yep.
I'm quite interested in the implications of research. So imagine if you find a rock art submerged there. Do you hope to learn more about the rock art? Do you hope to prevent oil and gas companies from having the activities there or something like that?
So, disclaimer, I should say that we're not trying to stop anything. That's what I need to say. I'm just doing a PhD project. I just have to make sure that's said. I've been told to make sure. But currently the heritage laws don't necessarily, so there's heritage laws that govern anything you do with any sort of rock art or heritage site in WA. Currently, they don't necessarily cover everything underwater because it depends how many metres you are of the coastline. I don't actually know the exact rules at the moment. Obviously, the laws that were brought in recently were drawn back. So the idea is to always try and conserve and protect any sort of heritage site because it does mean a lot to the local people, and you can actually draw a lot of information from rock art. For example, like especially in Murujuga, they know a lot about, well, first of all, where people lived, but also there's sort of animals that actually existed on the islands before the sea level rose. So, they know there's a lot of different animals that don't exist there now and that have gone extinct based on what people have drawn, because people draw what they see. And they also know that there's been people come down from Indonesia much earlier than they thought to go fishing and to trade with people based on some of the images and the types of boats that they have in rock art around the north coast. So those things are important to first of all analyse to see what we can learn about history from them, but then to preserve. So I don't know what their exact idea would be with these, but in Murujuga they've sometimes moved some rocks. So on land they've sometimes moved some rock arts, and other times they've just made pipelines or certain mining companies go around them. I don't know what they will do in the end, but it's always, first of all, try and conserve and protect. I imagine it would be to to probably go around and, you know, reduce. So the issue is that with that though is that you may end up going through another site you might not have identified. Yeah, that's up to the archaeologists and heritage protection people. I'm not touching that one. Yeah, it's a really good question though, because obviously why are you doing it? Like people say it to me all the time. Why? Like why would you look underwater? That's it. And you know, that was before I learned anything about it, that was me as well. But it's, you know, it's because it is important to a lot of people and to these Indigenous groups, and we can learn so much from the rock art as well, which sometimes we can back up with other sorts of sciences. Other times we don't have that information even available, so we've learnt new things from the rock art. But yeah, paramount being, you know, heritage and preserving that for local people. Yeah. Cool. Good. Any more questions? Thanks.
Thanks, Gabriel. Thanks for our sponsors, Ghost to Ocean.
Thank you for coming. Thanks for volunteering. Awesome. Let's have some pizza.
Thank you.